Okay, let's go ahead and do the second page. So what we have here is we have another quadratic equation, and you can see that this is a little different. We really don't have an x term. The x term we do have is in parentheses here, and it's being squared. So, and the other thing that I have is a number. So for this one, the easiest way is just to take the square root of both sides. So what I'm going to do is I'm going to take the square root of 2 minus x squared and I'll take the square root of the other side. Now the square root, as soon as I take the square root like that, I'm taking the square root of a squared term. I need to add a plus or minus. So I'm adding a plus or minus to the other side, and the square root of anything squared is just that number, so this will be 2 minus x on this side. And this next side, I'll have plus or minus the square root of a negative 100. So now let's simplify that. The negative will come out as an I, and the 100 will come out as a 10. So I'm going to have 2 minus x is equal to plus or minus I, or 10i. And I still don't have this x alone. So the next thing I'm going to subtract 2 from both sides. So if I subtract 2, I'm going to get a negative x is equal to a negative 2 plus or minus 10 I. So I still have a negative on the x. So let's divide that negative off. And what I'm going to end up with is x is equal to, now I have a negative 2 over 1, so that's going to be 2 plus or minus a negative 10i. Well, let's think about this negative 10i plus or minus. So if I would want to distribute this negative and change the sign that's in front of it, well, it's already got a plus or minus, so no matter what I do, it's still going to be okay. So I'm just going to take this negative and distribute it into the plus or minus, and it's still going to be plus or minus. Okay, let's move on to the next problem. Once again, we see that we don't have an x term. So as long as I can get all the numbers on one side and the part that's squared, which is just the x squared, not the 8, as long as I can get the x squared alone, I can take the square root of both sides. So my first step is to move the 6 over, so I'm going to subtract 6 from both sides, and that would leave me 8. X squared is equal to 128. Now I'm going to divide both sides by 8. And when I do that, I get x squared is equal to 8 will go into 12 one time, 48, so I get 16. Now let's take the square root of both sides. And when I do that, I have to make a plus or minus. And the square root of 16 is 4, so I will have x is equal to plus or minus 4. Let's move down to the next problem. So I need to get all the imaginary numbers out of the denominator. So to do that, I'm going to multiply both the numerator and the denominator by the complex conjugate of the denominator. So that would be a negative 7 minus 7i. So let's go ahead and work that out. I'm going to have to use the FOIL method. So 9 times negative 7, negative 63. 9 times another negative 7 is a minus 63i. 4i times a negative 7 is a minus 28i. 4i times a negative 7 is going to be a negative 28i squared. My denominator is going to be a negative 7 times negative 7, that's 49. Negative 7 times a negative 7i is going to be plus 49i. 7i times a negative 7 would be a negative 49i. Lastly, I have 7 times a negative 7. That'd be a minus 49, and the I times I is I squared. Let's simplify that. So I'm going to have a negative 63. I'm going to have a negative 63 minus 28. So that would be 91. And then I have I squared, which will turn this into a plus 28. My denominator will be 49. I have a plus 49 minus 49i, so those will go away, and I have I squared, which will change this 49 to plus 49. So I have a negative 63. Wait, hold on. I have negative 63 plus 28. That's a negative 35 minus 91i all over 98. So breaking that up, I get a negative 35 all over 98 minus 91i all over 98. And a 7 will divide into those. So if I divide the first part by a 7, simplify it, that's going to be a minus 5 over 14 minus dividing a 7 into 91, I get 13i. And dividing 7 into 98, I get 14. Okay, let's do the next one. So I'm going to take the numerator and the denominator by the complex conjugate. So that would be times 5 plus 6i over 5 plus 6i. 7 times 5 is 35. 7 times 6 is plus 42i. 5 times 5 is plus 25i. And lastly, 5 times 6 is 30. I get plus 30i squared. The denominator, 5 times 5 is 25. 5 times a plus 6 is plus 30i. Negative 6i times 5 is minus 30i. And lastly, a negative 6 times a positive 6 is a negative 36, and I have I squared. So let's simplify that. I will have 35. I have a plus 42i and a 25i. So that's going to be 67i. Then this 30i squared, I squared is a negative 1. That makes that a minus 30. My denominator will be 25. Plus 30 minus 30, so the i's go away. I squared is a negative 1, changes that to a plus 36. So now I have 35 minus 30, that's 5, plus 67i, all over 25 plus 36, which is 61. So breaking those up, which is the standard form for a complex number. The next one is just a FOIL method using complex numbers. So I'm going to take a negative 8 times a negative 4. That's a positive 32. A negative 8 times 7. That's a minus 56i. Now I have a negative 5 times a negative 4. That's plus 20i. And I have a negative 5 times the 7. That would be a negative 35. And I have I squared. Now let's combine the like terms. So I've got 32. I have a negative 56 plus 20. Well, that's a negative 36i. And then over here I have I squared, which is going to change that to negative 1. Mean that 35 would become positive. Now I'm going to combine 32 with the 35. That gives me 67 minus 36i. The next one is adding numbers that are imaginary. So I have 2 minus 6i. Now I distribute the plus, so that's plus 5. To distribute the plus to the 8i, which is plus 8i. Let's combine the number terms. So I have 2 plus 5 is 7. And I have a negative 6i plus 8i, which would be plus 2i. Okay, we have a couple more here on this page. Okay, next one is subtraction. of complex numbers, so this would be 3 plus 6i. Now, this minus sign will distribute in, making this a negative 5. The minus sign will distribute into the 5i, making that a negative 5i. So combining my number terms, 3 minus 5, that's a negative 2. And I have a 6i minus 5i, that'd be plus I. Next one is also an addition and subtraction. So let's go ahead and distribute the plus. So I have 2 plus 3i plus a negative 1 plus 5i. Combining like terms, I have 2 minus 1, that's 1. And I have a 3i plus a 5i, that would be 8i. Okay, and the next ones, we have to get rid of the radical in the denominator. So one way I could do this, I'm going to work the first one 2 ways, is I can simply say, okay, let's take the square root of 5 all over the square root of 125, and let's multiply it by whatever is in that radical. And so now in the numerator, I'm going to have 5 times 625. Well, that's 125. That's 625 in the numerator under square root. And the denominator would be the square root of 125 squared, which is what I want, because the square of 125, when I take the square root, will be 125. So what I'm going to have here is the square root of 625. That's actually 15. And in the denominator, then, I will have the square root of 125 squared, which would be 125. And when I simplify that, I get 1/5. So that wasn't too bad. Now, sometimes we may want to simplify what's in the square root in the denominator first. So I'm going to do it that way. I'm going to say the square root of 5 over the square root of 25 times 5. And this 25 will come out as a 5. So that's going to leave me with the square root of 5 all over 5 times the square root of 5. Now then, I don't have to multiply the numerator and the denominator by such a large number. It makes the numbers easier to work with. So since I have a square root of 5 in the denominator, I'm going to multiply both the numerator and the denominator by the square root of 5. So that'll give me the square root of 25 all over 5 times the square root of 25. That'll give me 5 over 5 times 5, which would give me 1/5. Okay, now let's look at the next one. And we always want to check to see if we have some perfect squares. That may make the problem simpler. And sure enough, the square root of 9 is actually 3, and the square root of 4 is 2. So that was an easy one to simplify.